These are the notes for section 11.4, finding the area formula for regular polygons. Remember, this is for regular polygons. And what we're going to do is we're going to divide these different regular polygons up into something we know, something we're familiar with, which is going to be isosceles triangles. So for each one of these, we go ahead from the center to each vertex. We divide them up and we see that all the sides are equal to each other. And so for the triangle, it forms 3 isosceles triangles. For a square, it'll be 4 isosceles triangles. For a pentagon, it'll be 5. For hexagon, 6. And so what do we need to find the area for each one of these? Well, it's just going to be, for each triangle, it's going to be 1/2 the base times the height. But to find the area of all of them, we need to multiply it by the number of triangles we have. So to do that, the base is going to become the perimeter of the whole thing. And that's adding up all those sides together. Let's do some vocabulary. The center is going to be the center of the polygon from the circumscribed circle. So that means that the polygon, the regular polygon, is inside the circle. And then the radius, it's coming up here, then the radius is going to be from that center to one of the vertices of that regular polygon. So the central angle is the angle formed by the 2 radii. And then the apothem is going to be the height of the triangles we form that goes from the center to the side of the regular polygon. So each triangle has their own apothem, but we only need to use one of them. We only have to use one apothem because they're all the same. We're going to write the area formula is going to be 1/2 the apothem times the perimeter. The apothem is going to be the height from the center to the side, and the perimeter is just going to be all the sides added up. And so that's how we're going to get how we find the area of the whole thing. Now, as we do this, remember the central angle for a triangle is going to be 120 degrees. So if we cut it in half, it's going to be 60 degrees towards, which is half the central angle. It's going to bisect the side, which is going to be 3 and 3. The perimeter is 18. So it's a 30, 60, 90 degree triangle. And so we just go ahead and put in everything, which is going to be 1/2 the square root of 3, which is the apothem, the height of one of the triangles, and then we multiply it by the perimeter, which is 18. We get our answer to be 9 square root of 3 centimeters squared. The central angle for a square is going to be 90 degrees. So we drop in the apothem, it cuts that angle in half, makes it a 45, 45, 90 degree triangle. So we get 6 square root of 2 to be the apothem, and then half the base is 6 square root of 2. So that means a whole base is 12 square root of 2, or the perimeter is 48 square root of 2. So we use our formula again, equal to 1/2 the apothem, 6 square root of 2, times the perimeter, which is 48 square root of 2. We multiply it together, and we get the answer that you got, which is going to be 288 inches squared. Now it's a hexagon. So the perimeter, we go ahead and find out, is going to be 108 millimeters. And so we know that central angle is going to be 60. So half of it's going to be 30. So we get a 30, 60, 90 degree triangle. Half the side is going to be 9, which makes the apothem, or that height of the one triangle, 9 square root of 3. Put it into our formula. 1/2 the apothem, which is 9 square root of 3, times the perimeter. And so you get our answer to be 486 square root of 3 millimeters squared. With a pentagon, we know that our central angle is no longer going to be 60 or 90 or 120, so we're going to have to use the Pythagorean theorem. We first go ahead and find out the perimeter is 120, so that means that the base, half the base, is going to be 12. Using the Pythagorean theorem, we get the apothem to be 9. And so we put it into our formula again. 1/2 times the apothem of 9 times the perimeter of 120. That pesky pentagon. And so we get our area to be 540 centimeters squared. And your magic word today, cylinder.